Now let's see gray code. So what are the properties of gray code and why it is important is it has got several properties. So one property is it is reflexive, and the other one is it has got unit distance. It is also called as unit distance code. I'll tell you what they mean. Okay. And the other one is it is also called as cyclic code, because these are all the properties it has. It is also called as cyclic code, and it belongs to the category of non-weighted codes, which means we cannot give any formula like 2's complement or binary numbers. Non-weighted code. Fine. So I'll tell you why it is called with all these names, and then it is not exactly same as BCD or 3321 code. The reason is this: in BCD or 3321 code, we are going to represent only from 0 to 9 and any number which is formed with the combination of these digits. For example, if you have 12, in BCD you are going to represent 1 as 0001 and then 2 as 0010, as if it is a collection of 8 bits, right? If you have 3, then you are going to represent with 0011, right? Therefore, in other codes, we are going to take each digit and then represent it using 4 bits. That is what we are doing. But then in gray code, we need not do that. So gray code is not just used to represent from 0 to 9, and we are not going to just use these combinations to form bigger numbers. It is just like binary number. If you remember binary, in binary we have the combination for 12 directly, isn't it? In binary numbers, 12 is 1100. We are not going to take 1 and write it in binary, and we are not going to take 2 and write it in binary. But then in BCD and then the other codes, 3321 or other codes, we are trying to actually separate them and then write them. In gray, we actually do the same as binary, which means for every number there will be a code which can be derived. So it is not depending on each digit individually, right? Let's see why it is called reflexive. Okay. Now with 1 bit, how many combinations are possible? Two combinations. Therefore, how many numbers can be represented? 2 numbers. So when I go with 1 bit, 2 combinations are possible. One is 0 and other is 1. One combination is used to represent 0 in decimal, and other combination is used to represent 1. Right? Now with 2 bits, how many combinations are possible? 4 combinations are possible. Therefore, we can represent 4 numbers, but then the way we derive or the way we represent the 4 numbers depends on the reflexive property. What I mean to say is, whatever you know from 1 bit, you write it here 0 and 1 in such a way that the least significant bit will contain these 0 and 1, and then you put a mirror here, and now you take the mirror image of this. So if I put a mirror here, 1 will appear here and 0 will appear here, isn't it? You just put a mirror and look into the mirror, 1 will be here and 0 will be here. So that is why it is called as reflexive, because it is reflecting this, right? And now to the upper half you give zeros, and to the lower half you give ones. Got it? And this one will be given as 0, this one will be representing 1, and this one will be representing 2, and this one will be representing 3. It is not actually binary, because in binary this has to represent 3 and this has to represent 2, but then it is gray code, and this is how we are doing the mapping. And now if you go for 1, 2, 3 bits, what you do is you just write all this with 2 combinations there, with these 2 bits there, and then put a mirror and take the reflex. So see this, it is 0 0 0 1 1 1 1 0. Now you put a mirror here, then we get the image 1 0 1 1 0 1 0 0. To the upper half you just give zeros, to the lower half you just give ones, right? And now this one is going to represent 0 1 2 3. This one is going to represent 4 5 6 7. Got it? And now if you want to do it for 4 bits, simply put a mirror here and you take the reflex of this. So what does it mean? 1 0 0 I'm just taking the reflex of all these 8, okay, and then 101, 111, 110, 010, so on, 000. You can fill it, okay. I'm just taking the reflection of that, and to the upper of we are going to put all zeros so that they are going to form 4 bits, and the lower of I'm going to put all ones so that we are going to get 4 ones, right. 8, 9, so on, 15. So if you observe this, earlier in the other number systems we are having in BCD and all, we are having only till 9s and the others were not formed, and we are going to use these combinations to form bigger numbers. But in this one we are going to form bigger numbers by simply extending this like this. So every number, every positive number including 0 will have a pattern from this, which will be having less number of bits, not like 84, that 8421 or 3321. I hope you are understanding this. Oh, don't worry, I'll take an example and explain you what it means. Okay, or we can take an example here. See this is 10, this is 11, and this is 12. Now tell me how to represent the number 12 in BCD. In BCD, if you have to represent number 12, I have to represent 1 and then 2, which means 0001 and then 0010. This is number 12. How to represent this number in 3321 code? In 3321 code, 1 is 0001 and 2 is 0010, right? Both are same. I mean, for this number it happened to be same. And now how to represent 12 in gray code? In gray code, 12 is represented with 1010. That's it, over. 1010. You need not have one more combination. How do you represent 12 in binary? 12 in binary is 1100. I hope you are getting the difference between all the representations, right? Okay, so that is how we represent them. Now let's come back to the points. So why is it called reflexive? Because we are going to, if we have to form the number system with n bits, we are going to take the number representation with n minus 1 bits, and then we are going to put a mirror, take the reflex, take the image, and then we are proceeding like that, right? So that is the reason this is called reflexive. And next thing is, why is it called unit distance? It is called unit distance because if you see the successive numbers, right, of 0 after 1 after 2 after 3, they just differ by 1 bit. For example, if you have to go from here to here, how many bits should you change? Only 1 bit. Therefore the distance between them is 1, right? And if you have to go from here to here, how many bits should you change? Only 1 bit. That bit is changed from 0 to 1, isn't it? So change is only 1, that is why the distance is 1, unit distance. If you have to go from here to here, you have to change only this bit. This one remains same, right? Therefore change is only 1, so it is unit distance. If you have to go from here to here, what is it change? This one, right? Therefore whenever you see these successive bits, the change is just 1. You can see the same here. The change is 1. Right, the change is 1, only this one. Now what is the advantage of that such a representation is, when you are counting sequentially, when you are going from 0 to 1, right, the output that has to be shown or output that you should get is simply changing in 1 bit, right? So if you use some other number system like binary, see, if I have to go from, let us say 0, 1, 2, yeah, it is 0, this is 1, this is 1, and then this is 2. If I have to go from 1 to 2, the problem is I have to change this bit to 0 as well as this bit to 1. So 2 changes are required. Now depending on the delays, if any of these changes occur first, you might end up in an intermediate inconsistent state. For example, let us say this bit changed early, then we end up with 0, 0 in the intermediate step, and then we go to this after some time, right? Therefore the result will be inconsistent for some time. So in such systems where you don't need such inconsistencies, if you want everything to be proper, then cyclic code is going to be useful because it is having unit distance code. I hope you got what I mean by unit distance. Generally what I mean by distance is, if you have two patterns, the number of changes that you have to make in one pattern to make it the other pattern, that is called as distance between the codes, I mean distance between those two numbers. Generally the distance is defined between two numbers, right? And here the code itself is having unit distance, which means you take any two successive numbers, they will be differing by 1 bit. So I'll tell you what I mean by the distance. Let us say I have a number 0010, this is a number, and I have one more number 1110. Now what is the distance between these two numbers? See how many bits you have to change in this one to get this one, or how many numbers, how many digits you should change in this one to get this one. So that is called as distance. So if you observe this, 0 is changed to 1, 0 is changed to 1, but these two need not be changed. Therefore two changes are required to convert one number to the other one. So the distance is 2. That is how we measure the distance. And now if you observe this here, the distance between every two successive numbers is simply 1. That is why it is called as unit distance code. And second thing is, it is called cyclic code. Why is it called cyclic? It is not just the distance between successive numbers, which is 1. Even you can see the distance between the last one and the first one. Even there the distance will be 1. See this. This is the last number, right? And it is 10 and it is 00. Therefore, in order to convert this one from here to here, you have to just change 1 bit. Therefore, even the distance here is 1. That is why it is called as cyclic. Now, the same thing is here also. In 15 to 0, you will check it. So, why is this true? Is because of the mirror imaging, isn't it? We have taken the mirror in such a way that whatever was this number here 000, the same number appears here. And then we are appending a 0 here, and then we are appending a 1 here. That makes it, that particular organization makes it in such a way that it is cyclic. Cyclic means the last one again differs by 1 bit from the first one. Therefore if you want to design a mod 15 counter from 0 till 15, when you are counting, only 1 bit has to be changed every time, and moreover after 15 again going back to 0, only 1 bit has to be changed. So that is the reason why it is more popular. And as I told you, it is not it is a non-weighted code. So what is the problem with non-weighted code? If you have weighted code, getting the representation for a number is easy. For example, if it is like binary, getting the number representation for 12 is easy, because we know that the weight of this one is 8, 4, 2, 1. Therefore we know 8 plus 4 is 12, we can directly get it. But then getting the representation, if it is not weighted, is somewhat difficult, because there are no weights. How can you know that this is 12? So we might have to write everything, and we might have to get it. What if I ask you, give me the representation for 100? So you might have to put the mirrors and then go till you get 100. So it is going to be hectic. I'll tell you some method by which we can convert a binary number to gray. So the easiest way is, given a number, find out its binary representation, and from binary you can convert to gray. And if they have given you some gray code, and if you want to find out the value what it is representing, convert it to binary and then go there. So I'll tell you the method by which you can do these conversions easily. Let's see those conversions now. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%. And IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%. But all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.